In this video, you will learn to expand powers of binomials. Now, before we get into expanding different binomials, we first must understand what we call Pascal's triangle. Now, what this is a triangle with a pattern. So notice here, these different numbers in this triangle. So the left side of each row in the triangle starts with number 1, and the right side also starts with the number 1. And now look at the third row right here. Okay, this third row, we have a 1 on the left and the right side, and this number right here is found by adding the two numbers above it, the 1 plus 1. Looking at the fourth row right here, if we take the 1 plus 2, that gives us the 3 right there, and then 2 plus 1 gives us 3 right here. And then for the next row, same thing. We have a 1 on the left side, and then 1 plus 3 gives you 4, 3 plus 3 is 6, 3 plus 1 is 4, and then the last number is a 1. This pattern will continue. So the next row is 1 plus 4 to get 5, 4 plus 6 gives you 10, 6 plus 4 gives you 10, and then 4 plus 1 gives you 5. And then the last row here in the picture, we have 1 plus 5 to get 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, and then 5 plus 1 is 6. So this pattern can keep going on to infinity. All right, so here we just have the first 7 rows. And this pattern within Pascal's triangle will be used here in a moment to expand different binomials. Now, as you look at this triangle we've created, the row up here at the top, the 1 by itself, that would technically be row 0. And then the next row is row 1, then row 2, 3, 4, 5, 6. Now, how does this relate to expanding binomials? So if we start with a plus b as our binomial, we raise that to the 0 power. Well, anything to the 0 power is 1. So notice the 1 is the same as the 1 over here in Pascal's triangle. Now, what about a plus b to the first power? Well, a plus b to the first power would just be a plus b, right? Or in other words, 1a plus 1b. That's the same thing. Now notice again the coefficients. We have 1 and 1, which notice over here in Pascal's triangle were the numbers found in row 1. Now, hopefully you're starting to see a pattern emerge. If we did a plus b to the second power, a plus b to the second power, when you expand this, you would get a squared plus 2ab plus b squared. And you can confirm this by distributing. If you did a plus b times a plus b, that's what you'd find as your result. Now again, notice the coefficients. We have here 1, 2, and 1. And notice those match up with row 2's numbers, 1, 2, and 1. Now again, the pattern will continue, a plus b to the third power. And as you can probably guess, our coefficients will be the numbers found in the third row in Pascal's triangle. And you would be correct. It's going to be 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. So again, notice the coefficients are the same thing as the numbers in row 3 in Pascal's triangle. And this pattern will continue, a plus b to the fourth power. The coefficients found for each term will be the numbers found in Pascal's triangle in the fourth row. And this would give us 1a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1b to the fourth power. So notice those coefficients are the same thing as the numbers found in row 4. And we can do this for a plus b to the fifth power and a plus b to the sixth power. And if you look at the fifth power, this fifth row here, again, those coefficients of 1, 5, 10, 10, 5, and 1 are the numbers found in row 5 of Pascal's triangle. Then a plus b to the sixth power, all these coefficients, 1, 6, 15, 20, 15, 6, and 1, all those are the same numbers found in row 6 of Pascal's triangle. All right, so notice the pattern with the blue and the yellow numbers. Row 0 corresponds with raising your binomial to the 0 power. row 1 corresponds with the first power, row 2, second power, row 3, third power, and etc. All right, so that's how you know which row in Pascal's triangle to look at to determine the coefficients. Now the other thing you should notice is the pattern with the variables. So let's take a look at, let's say here, this third row. This is when you can start seeing the pattern a little more clearly. All right, so we start with this first term, so the a. We start with that to whatever power we're raising the binomial to. So raising a plus b to the third power, so this is going to start off as a to the third power. And then for each term, the exponent with the variable a is going to decrease by 1. So notice in term 2, it's now going to be a squared, a to the second power. Third term is a to the first power. And the last term is a to the 0 power, or there's no a's. And then look at the b's, so the second variable. So the letter b, we start with 0 b's in the first term. Then we have b to the first power, and then b squared, and then b cubed. The exponents keep increasing by 1. And notice that each time, for each term, if you add the exponents of the variables, it will always equal 3. It will equal the exponent here that we're raising the binomial to, right? Because a squared b to the first power for the second term, 2 plus 1 is 3. For the third term, 3ab squared, we have a to the first power times b squared. You add 1 plus 2, that gives you 3. And then b cubed obviously has a 3 for the exponent. So as you progress with each row of this binomial expansion, notice that the variables for the first, the exponents for the first variable will decrease by 1 each time, and then the exponent with the second variable will increase by 1 each time. So let's take a look here at this fourth row, or I guess row 4. We have a plus b to the fourth power. So again, we already pointed out the coefficients are going to correspond with row 4 in Pascal's triangle, but now notice the variables. We started by raising a plus b to the fourth power, that is what we're trying to expand. So we start with a to the fourth power, and we start with 0 b's for that first term. Notice for each term following, we have a cubed, then squared, then the first power, and then no a's. So the a's, the exponents keep decreasing by 1, and then for the b's, we start with 0 b's, then we have 1, then 2, then 3, then 4 b's as we progress. All right, so that's going to be the pattern for each row in this binomial expansion. So make sure you know how to quickly expand a binomial by using a Pascal's triangle. Now, what if, instead of a and b inside the parentheses, what if we had something different? Let's say we had x and 3y. So here we have x plus 3y to the fourth power. So how do we expand this by using Pascal's triangle? So the process for any problem like this is you want to expand the this binomial by just imagining an a and a b in here. So for this one, you do a plus b to the fourth power instead of the x and 3y. So you do a plus b to the fourth power like we did in the last slide. And then at the end, we're going to replace the a with x and the b with 3y. And then simplify if needed. So let's try this one. So assuming we have Pascal's triangle, assuming we know how to get all these numbers, what we're going to do is, because we're raising this to the fourth power, we're going to look at row 4. Now, again, take note, we begin with row 0, and then row 1, 2, 3, 4. So we're going to look right here. All right, so as we showed in the previous slide, we can expand this, where each of these numbers are going to be the coefficients for each term. So we're going to have 5 terms total. So notice the coefficients are 1, 4, 6, 4, and 1. And then the variables, we start with a to the fourth power, then we have a to the third power, a squared, a to the first power, and then no a's for the last term. And then the b's, we'll start with 0 b's, and then we have 1b, 2 b's, 3 b's, and then 4 b's. So that is how you expand with a plus b to the fourth power. Now to finish off, we just replace the a with x and then the b with 3y. So anywhere we see an a, we're going to put x. Anywhere we see a b, we're going to put 3y. And that's what we do here in this next step. All right, so if you need to pause to look through what we did exactly, you can do that. But we just replace a with x and then b with 3y. So then from here, what we can do is we can just simplify. All right, so this first term, we have 1x to the 4th power. That's just going to be x to the 4th power. Second term, we have a 4 and then a 3. 4 times 3, it gives you 12. We have x cubed, and then we have the y. The third term, we have a 3y being squared. So we have a 3 being squared and a y being squared. So 3 squared is 9, and then times the 6 in the front, that gives you 54. Then we have x squared, and then the y is also squared. The next term, we have 4x and then 3y cubed. So if we do 3 cubed, that's 3 times 3 times 3, which is 27. Times that by 4, that gives you 108. And then we have the x, and then we have a y that's being cubed. And then the last term, we have 3 to the 4th power, which would be 81 times 1, which is still 81. And then we have the y as well to the 4th power. So this here would be your answer. We've expanded x plus 3y to the 4th power. Let's try another example. And here, the thing that is different is now we have a negative number. And also take note that there is no variable in the second term. So this is the same process, but it looks a little bit different. So again, our process will be to expand a plus b to the 4th power. So just imagine x and then minus 3 being an a and a b. And then at the end, we can replace the a with the x and then replace b with the negative 3. So to begin this expanding, it's going to be the same as the last problem. So a plus b to the 4th power. We're going to look at this row, and then those would be your coefficients, the 1, 4, 6, 4, and 1. And then your variables start with a to the 4th power, and then each term a decreases by 1, so a to the 3rd, a squared, a to the 1st, and then no a's. And then your b's will start with no b's, and then we have 1, 2, 3, and then 4 b's. So this is how you expand a plus b to the 4th power. Now to finish off, we can replace the a with x and the b with negative 3. And so anywhere you see an a, you put x. Anywhere you see a b, we put a negative 3. So that's what we see right here. Instead of a to the 4th, we have x to the 4th. Instead of a cubed, we have x cubed. Instead of a squared, we have x squared. Instead of a, we have x. And then for b, we have b here, we put a negative 3. B squared is negative 3 squared. Sorry, that was right here. Negative 3 is right there. Negative 3 squared is here. Then b cubed, we have negative 3 cubed. B to the 4th, we have negative 3 to the 4th power. All right, so now we can just simplify this. We now have, for the first term, x to the 4th power. Second term, we have 4 times a negative 3, which gives you a negative 12, x to the 3rd power. And then third term, we have negative 3 squared, which is a positive 9. And 9 times 6 would give you 54. So 54x squared. The next term, we have negative 3 cubed, which would be a negative 27, times 4 is going to be negative 108. So that is negative 108, and then we have x to the 1st power. And then the last term, we have negative 3 to the 4th power. It's going to be a positive 81 times the 1, which is still positive 81. So our expanded expression would be right here. So this would be our final answer. And notice that because of this minus 3, each term will be changing in sign. We start with a positive, then negative, positive, negative, positive. So that's a way to check as well. If this term is negative, then our signs are going to alternate back and forth. Now what we can do as well is use the fact that if you look at Pascal's triangle, there is symmetry. And we can use that symmetry to answer different questions about binomial expansion. So let's go back here actually for a moment and look at this Pascal's triangle. So notice the symmetry. The left side and the right side are the same, right? So like here, for example, row 3, notice the left side is the same as the right side. We have 1, 3, and then we have 1 and 3. And then for row 4, same thing, 6 is in the middle, and then the right side is 4 and 1, and then right side and left side both are 4 and 1. And then row 5, same thing, here's the middle, the right side and left side are identical. Row 6, 20 is in the center, and then the right and left side are both the same. So we can use that symmetry to answer different questions. So we were told that the first 3 terms of m plus n to the 8th power are m to the 8th power plus 8m to the 7th power times n plus 28m to the 6th power times n squared. And we are to write the last 3 terms. So the last 3 terms, the coefficients are going to be the same, 28, 8, and then 1. So we know that's going to be the case for the right side as well. So we have 28, and then we have 8, and then we have 1. That's going to be your left side, or your right side, sorry. So this would be your left side, and this would be our right side. All right, and now we need to figure out the variables. Okay, well, we started with m to the 8th power, so it's going to decrease, right? 8, 7, 6, 5, 4, 3, 2, 1, and then 0. So this last term is going to have 0 m's, and then second to last will have 1 m, and then this one will have 2 m's. And then looking at the n's, we start with 0 n, so we have 1, then 2, then 3, then 4, etc. So to finish off, this last term is going to be n to the 8th power, and then this is going to be 1 less than that, so n to the 7th power, and we have n to the 6th power. And it's all plus signs connecting, so it's going to be plus and a plus here and here. So the last 3 terms we have found would be this. All right, and maybe another way of thinking of this, when you're thinking through the variables, basically you're just kind of switching the variables. So like here, for example, instead of m to the 8th, it's going to be n to the 8th. Instead of m to the 7th, n to the 1st, we have n to the 7th, and then m to the 1st. And then instead of m to the 6th, n squared, we have n to the 6th, and then m squared. So the variables are basically changing on the right side, and then the coefficients are going to stay the same. So we have found, like we said, the last 3 terms of this binomial expansion. One more example. The last 3 terms of m plus n to the 9th power are listed right here. And we are to write the first 3 terms. So again, realize that there is symmetry with the coefficients and with the terms. So here the coefficients are 36, 9, and 1. All right, that's going to be the last 3 terms, 36, 9, and 1. So the first 3 terms are going to be symmetric, so it's going to be 1, then 9, then 36. So we have the coefficients, and now we just need to figure out the variables. So this last term was n to the 9th power, which means the first term is going to be m to the 9th power. The second term had n to the 8th, m to the 1st. So then over here it's going to be m to the 8th, and then n to the 1st. And then here we had 36 n to the 7th m squared. Now it's going to be 36m to the 7th, and then n squared. So that's going to be your first 3 terms. And the variables, by the way, you may want to keep the same order. Like here we had n and then m. It doesn't really matter, I guess, but you might want to keep it the same. So put the n first and then m second. So you could maybe write this as 1m to the 9th plus 9n m to the 8th power plus 36n squared m squared. So it really doesn't matter too much, and probably this original statement up here should have put the m first and then n, just keep it alphabetical. But whatever the question starts with, probably keep it in that same format. So either way, either of these would be our solution. So in this lesson, you have learned how to use Pascal's triangle to expand binomials. And that concludes our lesson for today. We will see you next time.